We're going to do more work with the mean value theorem today, but in this video, what we're going to do is one very specific example of how the mean value theorem can be applied, and that is to showing that certain equations have exactly one real solution or have at most one real solution. So in this case, we want to show that this equation, 3x minus 2 equals negative cosine x, has exactly one real solution. So let's rearrange this first and then think about what this actually means and see how we can use the mean value theorem. So I'm going to rearrange this so that this is equal to 0. And so I'll just add cosine to both sides. So I'm going to call this f of x is 3x minus 2 plus cosine of x. And we want to show that this is equal to 0. So we want to find a 0 to this function. And we want to show that there is exactly one 0. We're not actually looking for the 0. We're not going to say that if I plug in 0.5, I get 0 out. We just want to show that there is one. So what we're thinking here is that we want to show that this function crosses the x-axis once and never again. So there's really two parts to the problems like this. The first problem is showing that this function actually crosses the x-axis, because it's possible that the function is something like this and never crosses the x-axis, but we want to show that we're not in that scenario. So our first step here is going to be show that there is a solution, at least one. We don't care how many there are at this point. And so you might be thinking, well, I don't know what a solution to 3x minus 2 plus cosine x is. That's not quadratic. It's not factorable. I don't know what to do. And here's the beauty of calculus. We're not really looking for what that solution is. We just have to show that it exists. So if we see this example over here, if this function has a positive value and a negative value, then we're going to cross the x-axis. And that's because this function is continuous, so there can't be any jumps. So we have a continuous function. And let's try and find an x value that will make the y value positive and an x value that will make the y value negative, okay? And this might seem really hard to do, but it's really not. So let's plug our favorite x value in. My favorite x value to plug in is always 0. So let's look at f of 0. That's going to give us a starting point. So if I plug 0 in, I'm going to get 0 minus 2. Cosine of 0 is 1, so I'm going to get negative 1 out. So I got a negative value when I plugged 0 in, and so what that's going to look out of my graph is that I get something like this at 0. Okay, now I just have to plug any other x value in that gives me a positive number out. You can probably pick a number, try 2, 3, whatever you want to try. I'm going to be a little bit careful here because we've got cosine in here, so I'm going to pick a multiple of pi. I'm going to try pi and see if this works. If it doesn't work, I'll just try another number until I get something positive out. So if I plug pi in, I'm going to get 3 times pi minus 2. Cosine of pi is negative 1. So I have 3 pi minus 3. Pi is close to 3, so 3 pi is going to be close to 9. 9 minus 3, that's definitely a positive number. So this is, oh, sorry, up here that should have said greater than 0 or less than 0. And this is less than 0. So when I plug pi in, I'm getting a positive value out. Since this function is continuous, it can't do any kind of funky things to get between those 2 points. And so it has to cross the x-axis. What we just did doesn't tell us how many times it crosses the x-axis. This function could do something like this and cross the x-axis multiple times, but we know that it has to cross the x-axis at least once. All that I did right here is actually the intermediate value theorem from last semester. So we can say, let's make our conclusion here by the intermediate value theorem, f has at least 1 0. Okay, could have more than 1 0. Okay, but the problem asked us to show that there is exactly one real solution. So the next part is to show that there are no more solutions, that there's only one. So let's show there's only one solution. This is my favorite mathematical trick. This is where we're going to use the mean value theorem. And you probably would not think to do this without having somebody help you first. So if you're like, well, Dr. Krager, I would not have tried that on my own, that is okay. There are certain things in math that sometimes we just have to see somebody show us how to do first. And this is really one of those, but once you see me do it, hopefully you can recreate it elsewhere. So I claim we're going to use the mean value theorem here, so we should check our conditions. This function is made up of a polynomial piece, the 3x minus 2, and a cosine. Both of these functions are continuous and differentiable everywhere, so we don't have to worry about using the mean value theorem. Our conditions are satisfied, so this is continuous and differentiable everywhere. So we have to do that before we're ever going to try and use the mean value theorem. Okay, and so here's where we're going to start out doing something a little bit funky. So what I'm going to do is I want to show that there is only one solution. I'm going to start out by assuming that there are more than one solution. There is more than one solution. So assume f of x equals 0 has more than one solution. Okay, that's not what we're trying to show. So what we're going to hope is that along the way, we run into a problem. And if we run into a problem, that means that this original assumption is wrong and that there can only be one solution. What this is called mathematically is a proof by contradiction, and I absolutely love proofs by contradiction. They are so much fun. So yeah, if you guys want to see more proofs by contradiction in class, just ask me because I will happily show them to you, even if they're not calculus. So let's call those two solutions A and B. So we'll say f of A is equal to f of B is equal to 0. And we have to make this assumption that A and B are not the same number because otherwise that's not two different solutions. Okay. So let's apply the mean value theorem on the interval A to B. Okay, so the mean value theorem says there is some C on that interval so that f prime of C is f of A minus f of B. And let's change the order, f of B minus f of A. It doesn't really matter as long as I get the denominator correct, over B minus A. Okay, we notice that f of A and f of B are both equal to 0, so my numerator will be 0. My denominator will not be 0 since B and A are not equal to each other, so that's good. So we're going to get 0 out from this whole side of the equation because I have 0 over a number. So this is telling us that there should be some place where the derivative is 0. Let's go back and look at our function. Our function is 3x minus 2 plus cosine of x. Let's take its derivative. Its derivative is 3 minus sine of x. Okay, so there must be some place where 3 minus sine of x or sine of c is equal to 0. Okay, that doesn't seem problematic, but let's think a little bit about this. So this means that 3 has to be equal to sine of x. Do you remember trig well enough to remember that sine can never be bigger than 1 or less than -1? So sine is never equal to 3. There is no place that this happens. So this is a contradiction to the mean value theorem because the mean value theorem says there has to be a place where 3 is equal to sine of x, but 3 can't be equal to sine of x. So that means that my original assumption is wrong. And so what that means is that f can only have one solution. And we showed that there is one solution, so that means that we have exactly one. Okay, sometimes up here we say assume for a contradiction. That's usually a good practice, but we're not going to do tons of proofs by contradiction in this class. So hopefully that was helpful. We'll have some fun with examples like this and other examples in class.